In this video, we're going to talk about midsegments and just how that applies to different parts of your triangle. So first off, a midsegment of a triangle is a segment that connects the midpoints of two sides of the triangle together. So if you look at your picture over here on the right, the M is the midpoint, P is the midpoint, and N is the midpoint, and we know that because there are congruent pieces on each side of them. So that means that MP is one midsegment. Another one is PN, and the third midsegment is MN. So that just tells you the location of where they are and that we know that they're connecting midpoints together. So the midsegment theorem then says that the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side as well. So the midsegment is half the length of the third side. This means that if you look at the picture, DE is parallel to segment AC, since that's the third side in our triangle. And then that means that if I take the length of DE, so our midsegment itself, so the length of the midsegment is equal to half of the side that it's parallel to, so that is AC. There's another way you can think of it, because sometimes we can't always divide numbers in half, but it is easier to multiply. So if we double 2, so multiply 2 times our DE, so if you double the shorter piece, it should equal the longer one. So sometimes this is probably the one that I'm going to be using when I solve equations. It's not written that way in the textbook, but that's really what it is, if you think of it, because it is half the length of the other side. So if I know that AC is 20, that means that DE is 10. So if I start that DE is 5, then I double it to find my AC. So that would be a 10 then for the AC if DE was 5. So here's where we're going to actually figure those out, of the different dimensions and different sizes. So first off is DB. So DB is right here. If we know that DF and DE are midsegments, that means that D is the midpoint of AB. So that means it's half this length. So that means that DB needs to be 10. And that's because D is the midpoint. Then next, if we find the length of DF, that if you look at our picture, BC, if DF is a midsegment, then it would be half of the side that is parallel to. So if you take half of 26, that would be the length of DF. So DF is 13. Lastly is FE. So if I wanted to find the length of FE, which is not necessarily drawn in my picture, but I could still find it, is if I know that this side is 10 and DB is also 10. That tells me that AB itself is 20, so EF would have to be 10. And if you're wondering what that jingling is in the background, those are my dogs shaking their collars. So the next picture is, we need to figure out the side that's parallel to CD. So if you look in our picture, CD is right here. So the only side that would be parallel to it is PN. These two problems are ones that are like previous questions I've already worked through. So I want you to fill out your missing answer. So I want you to find the side that is parallel to QS in this first one, and I want you to find what the length of PQ is in your picture. So when you're ready to check your answer, go ahead and push play. Okay, so in the first one, if you look at your picture, QS is right here, so the side that would be parallel to it would be MN. Next, for the second picture, let me switch colors. So if we know that SU is 30, then PQ should be half of it, so that would be 15. In this first one, I'll work it out, and then the second one, I'm going to have you guys try it. So in this first one, remember what I said before, either you can set the midsegment equal to half of the longer side, or you can double the smaller side, so double the midsegment, and make that equal to the parallel side. So that's what I'm going to do in this first one. So I am going to take my midsegment, and I'm going to double it, so multiply it by 2, and then set it equal to the x plus 9. So the other way you could have done it is you could take the x plus 9 and take half of that, so 1/2 times x plus 9, and make that equal to 2x minus 3. The second way that I did it, it's a little more difficult to do that because if we take half of x, we're going to have to deal with decimals, and half of 9 does not come out nicely either. So it's easier if you double something, because then you don't have to worry about any fractions. I'm going to solve the one that's in purple, so we're going to get 2x times 2 is 4x, 2 times 3 is 6. Then to move variables from side to side, and I know some of you are getting a little iffy about this, I need to subtract the 1x. Next I need to add 6 to both sides. Lastly, I need to divide by 3. So in this first one I get x equals 5, and if I would have solved this red version of it, I would also get x equals 5. So you can try it that way if you would like. So next I want you to try this last one on your own. Go ahead and push pause, work it out by yourself, and then when you're ready to check your answer, you can push play. And again, that's my dog drinking her water in the background. All right, so to check your answer, these are the 2 different ways you could have set it up. So if you double the short side or short piece of CB to equal the long one, or you could have taken the third side of the triangle, so the x plus 29, and taken half of that to set it equal to the mid-segment. Again, personally, I would choose to do it the first way I did it, so doubling the mid-segment to make it equal to the third side of the triangle, instead of taking half of the side of the triangle to make it equal to the mid-segment, just because it's easier to double something than it is to take half of something with our numbers, unless you don't mind the decimals. So in the first one, you should have distributed, and you get 2x plus 38. When I solve this, I'm going to subtract my x again from both sides, so I get an x plus 38. And then I can subtract 38 from both sides, and I end up with a negative 9. Some of you might be thinking, well, how is it possible to get an x equals a negative number? And sometimes that does happen. So I know that on our previous section that we've covered that some of the questions you get that you do end up with a negative number, and that's okay as long as when you put it back into the picture, so back into our 2 x's, that the length of the sides are not negative. So in this case, if this is a negative 9, the whole length would be 10. This is a negative 9, the whole length would be 20. And then so then we do not get any negative numbers. So it does work.